Okay, in this video I'm just going to go through a couple polynomials and try to find the zeros and factors of those polynomials. That should get you through all the different kinds of ALEKS homework questions that you could possibly have about polynomials like this. So up at the top I've got h of x is 7x cubed plus 9x squared minus 12x minus 4. The goal is, depending on what the question says, it's either to find the zeros or the factors. I'll just do both so you can see how to do both. The plan starts out the same. The plan is find one zero or one factor. If we're lucky, we'll find all of them, but find at least one, and then we can use division to remove it and find the rest. I tried to write access. It didn't work very well. Okay, so let's try to find one zero or one factor. The easiest way to do that is to first take our list of all the possible rational zeros. So the possible rational zeros for this, possible rational zeros, in all the explanations they call it P over Q, but it's basically, it could be positive or negative. We want factors of 4, that constant term at the end, divided by factors of 7, and here you use the leading coefficient. So what are these things? Well, the factors of 4 are 1, 2, and 4. The factors of 7 are 1 and 7. So basically our list of possible rational zeros are, I'll do 1 divided by 1 and 7, 2 divided by 1 and 7, and 4 divided by 1 and 7. So there's 1, 2, 3, 4, 5, 6 times 2. There's 12 numbers here. I don't want to try all 12 numbers. As soon as I notice I need to try 12 numbers, I say, you know what's good at that is a calculator. So I pull up my calculator, go to y equals, and put in my polynomial. 7x cubed, 9x squared, minus 12x, minus 4. Go to zoom and press standard, which is 6. It draws me a graph. Now, I know that there's at least one nice answer here, and I know that if there are any nice answers at all, they're in the list that I have in the top right there. So it kind of looks like my possible nice answers are -2. That's where it crosses the axis there around -2. Maybe some very small negative fraction, and maybe +1. So those are the things that I think the answer might be. I'm going to try those out. The easiest way to try things on the calculator is hit trace, and then just type a number immediately. So like, I think -2 is the answer, so I type in -2 and press enter. Sure enough, -2 is a 0. So I know that from the graph, this is what I would show like on a test or something. I would say my TI-84 made this graph. It goes up, and then it comes down again before the axis, and then it goes back up again. This is at -2. Okay, that other one, I think it's at 1, so I'm going to try 1. I press trace and type 1 and hit enter. Sure enough, it's a 0. So this is another 0 here at x equals 1. So now I'm hoping that I can just get the other 0 here. If so, it needs to be a really small negative fraction. So it's probably either -1/7 or -2/7. I guess it could be -4/7. I'll just try some of those. So I'll trace at -4/7. Nope, -4/7 was not it. I'll try -2/7. Yes, it was -2/7 all along. So this point here is -2/7. From that, well, I mean, in this case, the calculator just found all the answers. Like, we could see them all on the graph. So the zeros, all of them came out to be rational numbers that were in our list. So the zeros are x equals -2, -2/7, or 1. And that's all the zeros. sometimes the question just asks you for the zeros, and sometimes you get lucky and you can just get them all from the graph. Even if you get all of the zeros from the graph, that doesn't tell you the factors. However, you do know that the factors, that each zero corresponds to a factor. So like x equals -2 corresponds to x plus 2. X equals -2/7 corresponds to x plus 2/7. And x equals 1 corresponds to x minus 1. The problem is if you multiply all these together, this cannot possibly equal h of x. You can see it. If you actually multiplied those three factors together, you would get a leading term of 7x cubed. No, these only multiply to x cubed. So, no, you have to fix this slightly. You need to multiply by 7. So you can keep all these factors, just multiply by 7, and then everything will line up correctly. So this is a factored form of our polynomial. If you think this is a little ugly, or depending on the homework system you might be using, maybe the homework system doesn't like this, you could pick where to put this 7. It looks a little bit nicer if I actually multiply the 7 into this middle factor. So then I would have x plus 2, 7x plus 2, and x minus 1. It just looks a little better. So depending on what the question's asking, you'll either give the answer as the zeros or the answer as the factors. Okay, it doesn't always go this well. Like, not all the answers are always visible on the graph. It's still useful to make this list of possible zeros to know what to test, but let's see one where they're not all on the graph. I think I have one here. Yeah, let's do this one. So let's again say that the goal is the zeros and the factors. Again, my setup is the same. I'm hoping to find 1 0 somehow, and if I'm lucky, I'll find all the zeros. So let's make a list of all the possible nice zeros, the possible nice zeros, the possible rational zeros. Come from plus or minus factors of 10 over factors of 2. And again, I'm using the constant term and the leading term. Factors of 10 are 1, 2, 5, 10. Factors of 2 are just 1 and 2. So I'll divide 1, 2, 5, and 10 by 1 and by 2. So here comes my list. 1 divided by 1, 1 divided by 2, 2 divided by 1, 2 divided by 2 I actually already have, so I don't list it again. 5 divided by 1, 5 divided by 2, 10 divided by 1, and 10 divided by 2 I also still already have. I have 10 divided by 2, so I won't list it again. So I ended up with 12 options again. I'm not plugging in all 12 of these numbers, no way. I'm going to ask the calculator to help me. So let me pull out my calculator again, go to y equals, and clear out my old polynomial, make room for the new polynomial. 2x cubed minus 13x squared plus 26x minus 10. Again, I'll ask it for a standard window. Okay, it doesn't look like I am as lucky as last time. Last time I could see all 3 zeros, and they all turned out to be in my list. This time I can't even see all 3 zeros. This one, though, hopefully is in my list. It looks like it's between 0 and 1. Only one of the numbers in my list is between 0 and 1, so it better be a half. Let's see if it works. I will hit trace and plug in a half. Yep, a half worked. So I got one of my zeros. It's x equals a half. However, this time I'm not so lucky. I don't have all the zeros, so I will have to use division to remove the x equals a half factor from the polynomial and see what happens. So I'm going to divide by x minus a half so that I can set up a factor tree. So I know x minus a half is one of the factors. I'm going to divide and see what's left when I factor out x minus a half. Let's do it. I can do synthetic division, which is nice. Bring down the 2. Multiply a half times 2. A half times 2 is 1. Add, get negative 12. Multiply a half times negative 12, that's negative 6. Add. Multiply a half times 20, that's 10. And add, and I got a remainder of 0, which is good. It needed to be a remainder of 0 because otherwise this wouldn't have been a 0. It wouldn't have divided evenly. So the other factor is 2x squared minus 12x plus 20. Okay, I can factor a 2 out of that, so I'm going to do that now. It's 2 times x squared, I guess, it's 2 times x squared minus 6x plus 10. So now all I have to do is break up this x squared minus 6x plus 10, and I'll be good. The problem is x squared minus 6x plus 10 doesn't factor very easily. Like, I can't think of two numbers that multiply to 10 and add up to negative 6. They definitely exist, but I can't find them. So I will break it up using the quadratic formula. If I was looking for the places where x squared minus 6x plus 10 was 0, I could get it with the quadratic formula. Get 6 plus or minus the square root of negative 4. Oh, come on. Okay. The square root of negative 4 is the square root of 4 times the square root of negative 1. And both of those are easy. The square root of 4 is just 2. The square root of negative 1 is called I. And then when I divide all this by 2, I get 3 plus or minus I. If you don't like the quadratic formula, like for example, I do not like the quadratic formula, you can always complete the square instead here. This is a different path. Instead, I would subtract 1 from both sides. Factor the left. And take the square root of both sides. I get a plus or minus when I square root both sides, and the square root of negative 1 is I. So either way, I end up with x is 3 plus or minus I. Okay, so it depends what the question is now. If the question is to find the zeros, can I get colors? Say the question is to find the zeros, well then we got them. We got x equals a half. I'm writing just above my head. X equals a half, x equals 3 plus I, and x equals 3 minus I. So if that's the goal, if the goal is the factors, or if the goal is the zeros, then this is the answer. I got 3 of them. It gets a little trickier if the goal is the factors. Now, it's not that much trickier, it's just a little bit trickier, but let's see how to do that. So say, where should I write this? It was a half and 3 plus or minus I. If these are my 3 zeros, well, every time you have a 0, you can turn it into a factor by finding x minus the 0. So the factors for x equals a half, the factor is x minus a half. No problem. For x equals 3 plus I have to do x minus 3 plus I. So you have to subtract 3 plus I here. It goes like this. Finally, I have to do x minus 3 minus I. So I have to subtract 3 minus I. That means I'll get minus 3 and plus I. To finish this up, the original polynomial had a 2x cubed at the beginning, and the way I've built this, it's not going to be 2x cubed. So I should put the 2 in here to make sure that I have the right leading coefficient. If you want, you could distribute the 2 just into the first factor here to make it look nicer. So then it would be 2x minus 1, x minus 3 minus I, and x minus 3 plus I. And this would be the linear factors for that last example. So that is that. No matter what your polynomial is, no matter how ugly it is, you should follow the same general outline. First, go looking for the nice zeros, and you have a list of possible nice zeros, of possible rational zeros. Go look for those on a calculator, probably. Any of them that you find on the calculator are kind of free. Like, take those and run. Sometimes you'll find all of them. Just go with it. Those are the answers. If you have to turn zeros into factors, you do x minus the zeros, and then make sure you have the right leading coefficient at the end. If things don't go well and you can't find all the zeros on the graph, it's no big deal. Use division. Division will break things down into a smaller piece, and the smaller piece has the rest of the zeros. So hopefully that does it. In this way, you can find all the zeros and all the factors of basically any polynomial, as long as it has at least one nice rational zero. Send me emails or questions in Alex anytime. Good luck.